Any real number can be written in scientific notation, and it's really easy to see if a real number is written in scientific notation by looking to see if it's in the form c times 10 to the n, where c is between 1 and 10, and n is any integer. So c could be 1, could be 2, could be 3.4, could be 7.8954321, etc. You could have as many numbers after the decimal as you want. N is any integer, so it could be 0 or 1 or 2 or 3, etc. It could be -1 or -2 or -3, because integers are the whole numbers right here, the negative whole numbers right there, and the magic number 0. Looking at these numbers, you'll notice they are not written in scientific notation. It's pretty easy to see. There's no times 10 to anything. We're going to rewrite them in scientific notation by moving the decimal place. If you move the decimal place to the left, you've got 10 times smaller. If you move it to the right, it's 10 times bigger. And you can do that as many times as you need until you get a C value between 1 and 10. So let's move this decimal place 1 to the left, 3.96. We just made the number 10 times smaller, so to make it the overall expression equal the same thing we started with, you're going to multiply by 10, and the invisible power is 1. These two are equal, except one is written in scientific notation, the one on the bottom. 0 points in scientific notation because 0.72 is less than 1. So we're going to move the decimal place 1 to the right, which made it 10 times bigger. So we need to balance that out by making it 10 times smaller by multiplying by 10 to the -1, which you all know is equal to 1 over 10, just as a side note. Now, 1200 is way too big. If we move the decimal place to the left once, we made it 10 times smaller, 100 times smaller, 1,000 times smaller. So if we made it 1,000 times smaller, we need to multiply it by 1,000 to balance out the movement of the decimal. Over here, we have 0.0003, which is way too small. 0.003, 10 times bigger, 100 times bigger, 1,000 times bigger, 10,000 times bigger. 10,000 is 4 zeros after the 1. So we just made it 10,000 times bigger, so we need to balance that out by multiplying by 1/10,000th, which is times 10 to the -4th. You'll notice that I put that the 0 after the decimal place. That helps clarify what you're writing a little bit. So we just went from numbers that were in decimal notation to scientific notation. Now let's go from scientific notation to decimal notation. 10 to the 4th simply means move the decimal place, move the decimal 4 to the right. And where you can make that easier for yourself is adding some zeros onto the end as placeholders. So move it 4 times. 1, 2, 3, 4. We have 643,00.0. So you end up with 64,300. This means 6 to the right. We put in some more placeholders like we did before so we can keep track of how many decimals we've moved. 1, 2, 3, 4, 5, 6, and the decimal place ends up right there. And we're left with 307200. And sometimes it's hard to keep track. Well, there it is, there it is, there it is, there it is, there it is. Oh, we need one more 0 here to make it 6.0. So we end up with 3,072,000. And to the -2 just means 2 to the right. 2 to the left. So put the zeros on the other side. So this is our original number, and move it 2 to the left. 1, 2. So the decimal place is now here. So our final answer is going to be 0.042. Moving on, we have something that's similar. We're moving 3 to the left. Put the original decimal down and add some zeros on to the left as placeholders. And let's move it 3. 1, 2, 3. The decimal point is right there. So now we have 0.00152, a pretty small number. So you can convert back and forth, scientific notation to decimal, decimal to scientific notation, but just remember, C must be between 1 and 10, and N must be an integer. So let's try some more involved questions, ones that multiplying what looks similar to what you've done before, and FOIL still applies. 1.4 times 7.6, and that's okay if you do on your calculator. And you're going to add to it 1.4 times 10 to the third. You're going to add to that 10 to the fourth times 7.6. You're going to add to that 10 to the fourth times 10 to the third. And you'll notice sometimes I put the x's in between. You don't have to, but you can. And you should if it's scientific notation. So 1.4 times 7.6, you can do that out. That's fine. 1.4 times 7.6, you end up with 10.64 plus 1.4 times 10 to the third. It's in scientific notation, that's okay. 7.6 times to the fourth. Notice how I switched them. That's fine. You can switch the order. And then you get 10 to the fourth times 10 to the third. And since they have the same base, you can add the power, so it's 10 to the seventh. Now the question is, can you simplify this any further? Not really, because you don't have any same bases. There's an invisible 10 to the 0 here. None of these are the same power, so you can't add them together. So that's as far as you can go there. You could use a calculator to get more decimals, but that's fine. Let's move on here. So now we have something that looks familiar, but it's to a negative power, and you're just going to distribute the power again. So there's an invisible 1 there. You distribute the powers, and you get 4.0 to the third times 10 to the negative 2 times 3. So that's going to be 64 times 10 to the negative 6. And this is not in scientific notation, but it's close. It's close, because 64 is not, it's greater than 10, but 10 to the negative 6 is okay. So let's make 64 10 times smaller by making it 6.4. But if we make that 10 times smaller, we need to make the other one 10 times bigger. We need to multiply 10 to the negative 6 times 10 to the first. And that's going to be 10 to the negative 6 plus 1, which is 10 to the negative fifth. So what we did there is we made 64 10 times smaller, but we made 10 to the negative 6 10 times bigger. So we have the same thing. This is in scientific notation right there. Moving on, we have division, and with the division question, you just set it up as a regular division question. Looks strange until you write it like this, and you end up with something that should look pretty familiar. You have some similar bases there. You have one fraction and another being multiplied together. 1.2 over 4.8 is just 1/4. And then you have 10 to the negative 1 minus negative 4. Remember, you subtract the exponent if it's the same base. So you have 0.25 times 10, and that's, remember, it's negative 1 plus 4 because it's minus a negative, 10 to the third. This, again, is close. It's not quite in scientific notation, but it is close because 0.25 is less than 1. We're going to make 0.25 10 times bigger, 2.5. But if we make that 10 times bigger, we need to make 10 cubed 10 times smaller and turn it into 10 squared. So this would be the final answer right there. And I will leave this as an exercise for you. There's your example problem. Make sure you get that done tonight. Moving on to an example word problem. In 1867, the United States purchased Alaska from Russia for $7.2 million. The total area of Alaska is about 3.78 times 10 to the 8th acres. What was the price per acre? So the price per acre is going to equal the amount spent over the number of acres. The amount spent was in dollars, and this is in acres right here. That's just the units right here. Units. So what did we spend? 7.2. And million is 6 zeros after the 1. 6 zeros after the 1 is going to be 10 to the 6th. So 7.2 million is 7.2 times 10 to the 6th over 3.78 times 10 to the 8th. We now have a similar situation to the one we had before. You can do that on your calculator. 7.2 divided by 3.78. And you get a pretty big decimal. And you end up with, keep the question on the screen, you end up with 1.90476, and it keeps going. I'm going to round that to, and let's round it a little bit, but we'll keep it there for now, times 10 to the 6th over 10 to the 8th. It's going to be 10 to the 6th minus 8. So let's round it to 3 decimal places. So we get 1.905 times 10 to the negative 2. And this is in dollars per acre. written like that, it doesn't really make sense. So there's a time for scientific notation, and there's a time not for scientific notation. Here's one that it doesn't really make sense that way. So let's go to decimal form. And that means move the decimal place 2 to the left. So we have 1.905. Let's put a bunch of zeros here as placeholders, and let's move the decimal point 2 to the left to right there. So we end up with 0.01905, and that's dollars per acre. Now, 1/100th of a dollar is 1 cent, so this right here is about 2 cents. So we bought Alaska for about 2 cents on the acre. That's not very much. As a bonus, find out how much land costs in average per acre in St. Johnsbury. Compare that to 2 cents per acre. Hope you found this helpful, and I will see you tomorrow in class.